We tend to look at the ground beneath our feet as something fixed and finished, matter locked in place, while the real drama of life plays out on top of it. But if you watch this surface over millions of years, it reveals a restless, churning engine. Evidence suggests that rocks and minerals function as the primary engine for biological development. On a planet with no geological pulse, there is no mechanism to produce oxygen, stabilize oceans, or sustain a biosphere. We can see the result of that missing pulse on Mars. Mars is a graveyard specifically because its internal geological engine stalled. When the surface locked up, its biological potential vanished. Minerals and living organisms have spent 4.5 billion years co-evolving. They are participants in a massive codependent recycling loop where biology shapes geology and geology feeds biology. Earth perfected this infinite survival loop over eons. But in the last few centuries, a single species has intervened, learning how to decouple itself from the cycle and, in the process, break it. Life functions as a massive geological force. Long before the very first trees appeared on land, microscopic organisms were already manufacturing the physical features of our planet. Billions of years ago, early microbes began releasing oxygen into the atmosphere. This gas reacted with the iron in the oceans, effectively rusting the Earth's crust and creating the vast iron ore deposits we mine today. In the oceans, microscopic plankton called coccolithophores build intricate shells from calcium carbonate. When they die, those shells sink, layering the seafloor in a mineral sediment that slowly compresses into solid stone. These towering, chalky white cliffs are the macroscopic result of that microscopic process. They are made of trillions of ancient skeletons, compressed and pushed upward to form the literal coastlines of the world. On land, organisms like lichens paved the way for forests. They chemically dissolved raw granite, extracting minerals and leaving behind the very first layers of topsoil, the material needed for the first roots to take hold. Biology actively constructs the landscape. Every mountain of limestone and every inch of topsoil was manufactured by living things to support future life. The Earth returns this favor through the rock cycle. This mechanism takes nutrients buried deep in the crust and distributes them back to the organisms on the surface. Wind serves as a global transport system. It lifts mineral dust from vast sand dunes and carries it across oceans, dropping iron and nutrients into the water to feed the plankton. In the deep tectonic cycle, plates pull old depleted sediment into the Earth's mantle. The rock is melted down and violently ejected back to the surface as fresh lava, replenishing the planet with new minerals. Mountains erode into dust, feeding the sea. Sea life sinks underground, and volcanoes erupt, forming new mountains. In this perfectly closed economy, nothing is wasted. The death of one era provides the exact material needed for the next. Human history began within this loop. When our ancestors stepped onto the savanna, our brain evolution was tied to our ability to find specific rocks and deliberately shape them into tools. Our survival depended on navigating the mineral world. But the Industrial Revolution marked a shift. Humanity moved away from co-evolving with the rock cycle and toward a model of pure extraction. We developed a linear system. We pull ancient, compressed materials out of the ground, consume them for a brief moment of energy or utility, and then discard the remains as waste. The scale of this extraction is permanent. We are removing finite resources millions of times faster than geological time can replace them. This linear path reaches into the deep oceans, where we tap into the Earth's most isolated, ancient carbon reserves, pulling up the remains of biology that were meant to stay buried. Modern civilization is now built on the habit of breaking the Earth's circular logic. We take from the crust, but we return nothing the natural cycle can use. Beyond extraction, we are now layering the crust with synthetic material. Humans are forging a unique geological stratum that will persist for millions of years. Consider concrete. We have produced over 500 billion tons of it. That is enough material to coat every single square meter of the planet, sealing the Earth's natural surface under a layer of artificial stone. Our plastic waste is even merging with the landscape. In coastal areas, heat and pressure are fusing plastic debris with natural sediment, creating a new type of rock called plastiglomerates. This carpet of synthetic waste is being integrated into the physical crust. Plastic has become the raw material for a new, toxic rock cycle. This inescapable layer of concrete and plastic defines our era. We have officially entered the Anthropocene, a geological epoch characterized by a human-made layer of waste. To survive our own geological era, we must abandon this linear path. We have to learn to listen to the slow, circular rhythms of the Earth before we permanently silence the engine that sustains us.